Hi folks, this is your Professor Kent Schwitkus again. We're going to be talking about the solar system fossils, asteroid, comets, Kuiper belt, Oort cloud, things like that. One of the things I want to start off with is heading out to the Minor Planet Center. This is one of our NASA websites, and you can see that this is an area of interest. People who are scientists, or if you will, amateur scientists, so NASA folks, ESA folks, you and me could actually increase this tally. Okay, so we have a number of things here, and like any of these websites, NASA websites, I would suggest you go there. Very interesting stuff. You don't have to go and see the magazine articles at the grocery store. You can actually get it from NASA itself. All right, so let's talk about these various objects here. So we've taken a look at the NASA website. One of the other interesting things that you might be interested in is this B612 Foundation, started by Piet Hut, Ed Lu, and Rusty Schweikert, the astronaut. They are interested in trying to figure out ways to remove asteroids as a way of destroying the Earth or destroying our civilization. Obviously, an asteroid running into the Earth is not going to destroy it, but it would pretty much be the end of us on the planet. As you know, this type of plot is used frequently in Hollywood for, the end of the Earth type scenarios. So like Armageddon being one of them. But the B612 Foundation is a pretty interesting organization. They're intending to put up a satellite, and I think there are some programs on NOVA or something like that that describe what they're doing. So that would be something interesting to follow up on. Let's see. Also, in terms of asteroids, we basically don't see them when they approach us from the sun, from that direction, but we do see them when they approach us in the opposite direction. So the same time that we missed the Chebyshev event in Russia in 2014, we observed an asteroid called DA14, and we observed it and predicted its motion. It was 50 meters in size, and it got within 17,000 miles of altitude with respect to us. Mind you, our geosynchronous satellites are orbiting at 42,000 miles of altitude, I believe, or maybe that's kilometers. I'll have to check my notes on that. Let's see. Yeah, 42,000 kilometers. So 42,000 kilometers, 6/10 of that is that in miles. Okay. There was the Tunguska event, which was a pretty huge one as well, that occurred in Russia. Russia seems to be getting most of these things, but remember, it is the largest, biggest landmass country. The B612 Foundation is intending to build a satellite, the Sentinel, which is going to be launched in 2018, and it's going to be looking for these objects. They're hoping to find things that are 140 meters and larger. The way that we can deal with these asteroids as far as moving them so they don't hit us is by gravity tugs, perhaps getting them very, very hot, so a thing called solar sublimation, or shoot them down, or create an inelastic collision or something like that. But one has to be careful about shooting them down because you blow them up, and now instead of one object, you're going to have a million objects that are going to be running into you. So that's the biggest effect. All right. So the asteroid belt was originally, we originally observed asteroids that were the very largest ones there. And people were expecting to see a planet there. And the reason that they thought that there was a planet there was because of this Titus-Bode law. If you look at the orbits of the planets about the Sun, you see that they come in a specific distance from the Sun, and people were looking for characteristics between these orbits, expecting them to have some hidden meaning. And it's sort of numerology, if you would think that. So if you take a look at the orbits and the distances of these objects from the Sun, then you could apply them to a law that looks very similar to m plus 4 over 10. So here would be Mercury, here would be Venus, here's the Earth, here's Mars, here's Jupiter, and here's Saturn. Mind you, we're only talking about the visible planets. And this sequence works very well, except for this one, there's nothing here. But this turns out to be where the asteroid belt is. And so people are saying, well, there ought to be something there, and let's look for it. And so they did. And one of these guys that they found was Ceres, and over the next 30 years, they found hundreds more. Okay? There's no missing planet there. There's not enough material there to actually construct something that's even as large as the moon. And here are the largest ones, and you see they're kind of small. Remind you that the diameter of the Earth is about 12,000 kilometers. And remembering that the moon is about a third to a fourth the size of the Earth, then the moon just dominates the size of these guys as well. And if you add up all the material of these asteroids, you don't get anything that's very large. Let's see, there are something like 100,000 of these asteroids charted, and 2,000 follow orbits that are in the inner solar system. 200 or over 100 kilometers in diameter. There are tens of thousands that are 10 kilometers in diameter, and 1 million that are over a kilometer in size. Now, how do you determine, that you got something out there? What do you look for in the night sky? Well, basically you're looking for something like this. Let me turn on the highlight for you, and you're basically looking for how these objects appear versus the fixed stars. Okay, we can go to the main screen and we can see some other ones like this. Oh, you didn't see it? Okay, well, let me turn on the highlight. Okay, so you're basically looking for a streak on your photographic plate, or in your view screen. Now, you're not really going to see it in terms of just looking at it, but you've seen shooting stars in the night sky. This is sort of the same thing. You would be looking for shooting stars as you take a picture of the night sky. Okay? All right. So we can figure out the mass of some of these asteroids by if an asteroid has a little asteroid orbiting around it using Newton's laws of gravity. And the origin of the asteroid belt is basically, the same way as the formation of the solar system in general. We have all these materials rocks and sort of things in this region between Jupiter and Mars. And a planet really couldn't form there because Jupiter was tugging on it so strongly. In fact, we can see the spin or the orbit couplings that we see with Saturn's rings being imposed by Jupiter on the asteroid belt. So there are regions which are cleared out of material, just like we see in Saturn's rings. So Jupiter has a significant impact on what's going on in this region here. And so the planet couldn't form. These asteroids have particular types of materials on them, rocks, metals, and other things as well. And they do run into the Earth. There's something on the order of 100 tons of materials, meteoroids hitting the Earth each day. Most of them are very, very small. The stony meteorites, if you're less than 100 meters in size, you're going to burn up before you hit the ground. And an iron meteorite, if you're 40 meters in size, you'll burn up as well. But if you're above that size, then you'll hit the Earth. Now, if you wanted to, this is kind of a fun simulation to look at. And you could, basically run things into the Earth. And I especially like this particular one because it says kaboom. So we'll make this guy 1 kilometer in size, and we'll run it into the Earth. And one of the things I wanted to show you on this thing is this picture here. And we'll spend a little bit more time on that. And basically, it's only because we have launched satellites into orbit about the Earth, and we're looking back at the Earth, that we discovered that the Earth has all these artifacts of asteroid impacts. Pretty surprising. I mean, if you just were wandering around on the Earth and came across this thing, you would see, oh, there's a lake or a bay here or something like that, and you wouldn't make any notice of it. But when you look at it from up on high, you see, oh, that's a crater that's impacted the Earth. And so here are some other ones that we have pictures for. And basically, I want to point this out to you, is that the Earth hasn't covered up by its resurfacing all of these artifacts. And so things do strike the Earth. And it's pretty amazing that we can observe these things now. So science continues to go on its merry way. So going back to this crater simulation thing that we had seen, we'll run back and basically gives us the information on this guy. On this one was a pretty big one, 5 kilometers in size. A rocky asteroid, and it's going to create an earthquake like none has ever been observed on the Earth. A crater diameter about the size of the LA Basin, about as deep as the Palos Verdes Peninsula is high. 1 kilometer is 1,000 meters, which is about 3,000 feet. So the Palos Verdes Peninsula is 1,500 feet high. Okay, so this is pretty deep. They would be, it would really hurt you. At any rate, let's continue on. Significance of these things is occasionally these asteroids, when especially when they're very large, they can create mass extinctions on the Earth. There are 2 of them that, if you research the mass extinctions, have perhaps been caused by comets or asteroids. This one took out the dinosaurs. Alvarez predicted that an asteroid did hit the Earth at this particular moment in time. And Pemex, a few years after Alvarez made this prediction, if you will, from evidence of this, let's see, which the Cretaceous layer, there's iridium in this layer, and iridium comes from extraterrestrial sources, because iridium is so dense and it would go down to the Earth's core. It isn't in the Earth's crust. So there was an overabundance of this material in this layer, and so it corresponds to a particular date. That date is where, before that you had dinosaur fossils, after it you didn't, and so he predicted this. And you probably have seen simulations of what happened. Basically, you have this tremendous fireball being created after the event. You've seen, on the planet's video from the BBC, that when you have these things striking the Earth, they get very, very hot, and they essentially cause everything in the neighborhood to catch on fire. All this material gets thrown up in the air. It's really superheated, and the Earth rotates underneath it, and all this material that's superheated falls back onto the planet, which causes more forest fires, and then you have, a global nighttime occurring. So the Earth goes into, freezes out, everything gets burned up, and everything dies. Okay, there are 5 mass extinctions, and as I pointed out, 2 of them perhaps are associated with this type of event. Thank God, as it says, it doesn't happen that very, very often. The event that occurred in Russia not too long ago, this is some details from it. It comes from my data here. It comes from Physics Today, the September 2014 issue. It's very interesting that we know so much about this guy. We know the strength of the airburst because of the monitoring of the test ban treaty, and we know this, very accurately, very interesting. And we know the size of this thing pretty well, and from a variety of sources. There are lots of videos of this event occurring, you can see on YouTube, and they have an idea of how big this thing is, and by digging up the particles of this asteroid that hit, they were able to do some radioactive analysis, and then we find out the history. And we can go back to 30 million years after the solar system was formed. So we know the history of this guy, and therefore the solar system, pretty well. It's pretty amazing that we have this information available to us. Now, as I pointed out before, we know what happened with this asteroid, and this one was an unexpected event, but at the same time there was an expected event from the A081 asteroid, and here, let me remind you about the B612 Foundation and its Sentinel project. The Tunguska event was much stronger because it was the Tunguska event was much stronger than this one because it was a much higher angle than this one. This was a shallow angle. So a lot of energy of this asteroid was used up in the atmosphere. If it comes at a steep angle, then it goes and strikes the ground. And if you recall, the Tunguska event was mentioned in Ghostbusters. So a shout out to that. The original Ghostbusters, but I haven't seen the new one, the remake. Okay, let's go to the near-Earth observation. Apophis is one that was thought to was going to strike the Earth, and we have since obtained data on this satellite of the Sun, this asteroid. Its closest approach is going to be 23,000 kilometers. Let me remind you that geosynchronous satellites orbit at 40,000 kilometers of altitude. This guy is pretty big. It's not going to strike the Earth, but it's going to be a tremendous sight to see in the night sky. The two closest approaches are going to be in 2029 and 2036. It's going to be so close that it's going to move across the sky in a 42-degree amount. So, from, a significant portion of the sky. Remember, from the horizon to your zenith, directly above your head, that's 90 degrees. So we're talking about half of that across the span of the sky is what this guy is going to do. Let's go to the Near Earth Orbiting Program. This is another NASA website that I think you should take a look at, just because this is where they deposit information, and if you will, this is sort of peer-reviewed as well. So very interesting that we can actually get it from the horse's mouth, if you will, the actual data that people are collecting. Current analysis of the Barringer crater. You don't want to be very close to it. A lot of this information is old. Let me point out to you that I have climbed down to the bottom of this crater and back up when I was young. I don't think you can do that anymore. It's sort of disappointing. I don't know why they do that sort of thing. I think it's owned by a particular person, and that's why. Anyway, if you were anywhere close to it, it'd be a very bad day. Yeah, this is one of the scary things, is that we know 90% of the objects that are greater than 1 kilometer in size. What does that mean for things that are smaller than 1 kilometer in size? You don't know where those are. And even, what about those 10% of the objects that we don't know where they are? Oh boy. So, big deal. Okay, that's it for this one. We'll pick up again talking about comets.